Hi, welcome to this channel. Now we'll discuss about the photovoltaic cell or solar cells and the components of the PV system. And this components, the sunlight directly hits the solar cells, then the light directly changes to electricity. So from this video, we will discuss the components of solar system. The first component is the PV module, and second the battery, and the third charge controller, and uh, finally we will discuss about the inverter. So these are the basic components of solar PV system. So when we see the PV module, this is the main component. The PV module. PV module is a combination of photovoltaic cells, which converts sunlight to direct current DC current. Now this is the PV module. These are connected in parallel. We'll discuss after a while in this video what it will looks like when we connected in parallel. Uh, so the other component also the charge controller. What is the purpose of charge controller? So which used to charge controller used to control the maybe overflow control overflow of charges and the system to be safe. So the charge controller used to control electricity flow between uh, the components from we listed above. So between that components uh, control electricity flow between solar panel and battery and load. This is solar charge controller. As you see, there is different components installed with this charge controller. The other also a battery. Battery is another component and used to store uh, excess electricity, control or storage. So when the light directly hits the PV system, there is an excess electricity. That excess electricity is stored on the battery. So battery used to store excess electricity or DC charge generated by PV system. This is the batteries. One, two, three. There are four batteries. These four batteries are connected in parallel. In parallel. That means plus port connected to plus, minus connected to minus. We will see this after a while. The other component is in this case the inverter. Inverter used to convert convert direct current or DC. This is DC means direct current. Direct current converted to AC or alternative current. This is the purpose of inverter. So this inverter is the main component in the solar
And
system.
this
This
is
is an
a
inverter.
solar inverter, sine wave inverter, which converts direct current to alternating currents. So from the above listed components, how to connect them in parallel. Now we'll discuss them schematically, how we connect them. We will discuss each of them. Here is the sunlight. So sunlight directly hits the PV or the solar panel. Let's take two panels, PV1 and PV2. So by taking these two panels, then we connect them in parallel. And we take for this case these four batteries and an inverter, and this is a charge controller, and these are the batteries as is an inverter. And the other also, finally we have AC load. Now we will see how to connect them in parallel. Um, their connection ports have a sign, a plus and a negative sign. To connect them in parallel, the plus sign connected to the plus sign. So by connecting, uh, let's connect them. Here is the minus sign. This is a minus sign. If the color, the blue pen is and the red pen is the plus, the blue pen is the minus. This port is the first port is a PV port, and the second the battery, and this is third the DC load of the charge controller. Now let us connect them. The plus port connected to the plus of the PV, and then connect to the charge controller of the plus port, and uh, the minus ports of the PV1 connected to the minus of the PV2 and connect to the charge controller of the minus side. Then let us connect the batteries. The minus of the battery connected to the minus of the another battery and the minus of the inverter. Then this all connected to the charge controller of the minus side of the battery port and the plus connected to the plus of the batteries and the plus of the inverter and all connected to the charge controller minus side, the plus side, sorry. Then finally we connect them to the load. So inverter in this case the DC current converted to AC current. This is the parallel connection of the PV system, the solar PV system. So the parallel case would be the voltage, the currents. Now, if the batteries are connected in parallel and the PV1, PV2 connected in parallel, what would be the voltage? Level 6. Okay, PV1 and PV2 connected in parallel and the voltage connected in parallel. Uh, as you see, this connection in the above voltage in this case in parallel connection will be the same or constant. But what will be the current? What will be the current? The current will be increased as the panel increase or it will be sum up. The current in parallel uh, will be sum up. Sum up. This is and due to this current and voltage, an electric field also created and power also generated, or the multiplication of the current and voltage produce power. We'll see after a while the current and voltage calculation in parallel as well as in series. So this is current in parallel will be sum up or as the number of panels increases, the current will be increased. This is so. Uh, this is all in parallel connection of PV system. PV system. Let's discuss some examples. Some examples of parallel connection and how to calculate the current, the voltage, and finally the power. First, the parallel connection. In parallel connection, we said that current is voltage is constant and the current is sum up. But let's explain. Let's explain by taking example. So this is an parallel connection. This parallel connection. Let us the voltage 12 volts, and if resistance 1 and resistance 2, all these are as take as a loads. If connect them in parallel, what will be the current, what will be the voltage, what will be the power? Let's explain them in example. First, a voltage is the same in parallel connection. Parallel system voltage is the same. V is equal to V1 is equal to V2 is equal to 12 volts. This is from the given example 12 volts. The RT means total resistance. The total what will be the total resistance in parallel. To calculate the total resistance, 1 over R total is equal to 1 over R1 plus 1 over R2. R1 is 8 ohm, this example, and R2 is 3 ohm, this example. So the 1 over R total is equal to 1 over 1 over 8 ohm plus 1 over 3 ohm. So 24 is the 24 divided by 8, 3 ohm, and 24 divided by 3, 8 ohm, 3 plus 8, 11 ohm over 24 ohm. So 1 over RT which is equal to 11 ohm over 24 ohm. So RT proportionally the reciprocal. We take the reciprocal and the 24 over 11 ohm. So RT 24 ohm over 11 ohm 2.18 ohm will be R total. This is the total resistance when connected parallel. What will be the current? So current in parallel will be sum. So first we have to calculate from this formula. V is equal to R total times I current. So the I from this formula I is equal to V over R total. This V is 12 volt over R total is 2.18 ohm. So I is equal to 5.5 ampere. So finally, uh, what is left? What is left? The power. Calculate power. The power is equal to V times I, or voltage times current. The voltage is 12 volts and the current so 5.5 ampere. So the multiplication of 2 gives power So finally, the output power will be 66 VA or watts. VA means the power. So 66 watts power will be generated due to this voltage and current. Now, from this connection, since current is the sum up, current is sum up and the voltage is constant, we said before. So to prove this, is current I1 plus I2 and I1 voltage over R1 and 12 divided by 8, 1.5 ampere is on resistance 1 and the current on resistance 2 is 12 volt over 3 ohm 4 ampere. So the total current I1 plus I2 is 1.5 ampere plus 4 ampere. This gives us the 5.5 ampere. This is how to prove the current. So if these components, if the solar resistors or the components connects in series, what will be current? What will be voltage? What will be power? Let's take an example and discuss. Let's take this circuit. This circuit is series is if we take a voltage 12 volt and the load or the resistance R1 is equal to 5 ohm and R2 which is equal to 3 ohm, and here is V1 and here is V2 and here is also the the current. So the current flows in this I1 and current flow on R2 is I2 and um, in this connection what will be the voltage? Voltage in series will be sum up or voltage in series increased as the panel increases, the number of panels increases. So as you look, the voltage series connection sum means V is equal to V1 plus V2 as in this example given 12 volts. And the current in series is the same or constant. Means the given the current I, which is equal to I1, which is equal to I2. And what will be the total resistance? The total resistance or these resistances are loads. So this total resistance R1 plus R2. This is 5 ohm R1 and R2 3 ohm gives 8 ohm. This is the total resistance. Then what will be the current? Current is calculated from this V total equal to R total times the current total. So from this I is equal to voltage over resistance R total. The given voltage 12 volts over sum up the above total 8 ohm. So 12 divided by 8 give us I from this, and you divide this, the 1.5 ampere will be the current flow in this series connection and in this series circuit. So the what is left? What is left? Mm, so if current is constant, I is equal to I1 is equal to I2. So current is the same, so current 0.5 ampere. Since the voltage is a sum up in connection, series connection. So what will be the voltage? V1 which is equal to R1 times I1. Since R1 is 5 ohm and I1 is 1.5 ampere, then the voltage 1 is 7.5 volt. And the voltage 2 or V2 is R2 times I2. R2 is 3 ohm and I2 is 1.5 ampere. So V2 is 4.5 volts. So the total voltage V is equal to V1 plus V2, then 7.5 volt times plus 4.5 volt gives us 12 watts. What is left? It's left. Uh, then finally, what will be the power? Power is multiplication of voltage and current. So there is V total and there is a current total. The total voltage 12 volt times total current 1.5 ampere. Then when we multiply them, 18 VA or 18 watts will be the total power. So this is all about the parallel and series presented you. Like these important and educational videos, please like these videos and subscribe. Thank you for watching.